Hello viewers, welcome. In this video, we see how to make an obstacle detection circuit using radar. The main components of this circuit are Arduino Nano, servo motor, ultrasonic sensor and breadboard. As you can see in the circuit mainly consists ultrasonic sensor. Ultrasonic sensor consists 4 pins VCC, ground, trigger and echo pin. Ultrasonic sensor is having two eyes, which is to transmit the sound wave and to receive it. And the other component of this circuit is servo motor. Servo motor consists 3 pins VCC, ground and PWM pin. These trigger and echo pins acts as both input and output pins, that are IO pins. And we have an Arduino here which is used to initialize the servo motor and ultrasonic sensor. This Arduino will give the instruction to the software. We use process 3. Let us see the connections. Arduino have 5 volt pin and ground pin. So these VCC pins are connected together and given to Arduino 5 volt pin, and ground pins are also connected together and given to ground pin of Arduino. This trigger pin is given to Arduino 10th pin, and echo is given to 11th pin of Arduino, and PWM pin of servo motor will be given to 12th pin of Arduino. This Arduino Nano will send the instructions to software. Initially, whenever an obstacle is across the ultrasonic sensor, as one eye of the ultrasonic sensor will send the sound waves that are given by this Arduino using a trigger. This trigger is of 40 Hz frequency. Whenever this 40 Hz sound wave is traveled into air, it will be reflected by an object. This wave is being received by the ultrasonic sensor's second eye, and through the echo pin it will be giving to the Arduino. If you see here, the echo pin will calculate the distance by using this formula: duration into 0.034 divided by 2. So this duration is nothing but the time taken by the sound wave to travel from the sensor and to the sensor again. The data that is collected by this Arduino will be given to the process 3 software, in which we can see the distance and height, length of the obstacle in the way. The servo motor is used to rotate this sensor from 0 degrees to 180 degrees. I have written the code in such a way that the servo motor will start at 0 degrees and end up at 180 degrees. Again, it will return to 0 degrees and start from 0 and ends up at 180 degrees. You can modify your code. The servo motor has to start at 0 degrees and ends up at 180, and it will start again at 180 and ends up at 0. Let us see how the circuit works. I have already installed process 3 software in my laptop. This is the Arduino IDE software, and I have already installed process 3 software here. This is the code for radar. You can get this in the video's description. As soon as you connect the Arduino cable, you will be seeing that the port COM10 here. The port number will depend on to which port you are connecting that are with your laptop. So I have selected this port by going to tools in the Arduino software. Now you have to go to process 3 software and open your file and edit here as you have connected to port 10. Now run the program. You will get a screen like this. If you see the circuit now, this is the servo motor, this is the ultrasonic sensor, and this is Arduino Nano. This servo motor is making the ultrasonic sensor to rotate from 0 to 180 degrees and from again starting at 0 and ending up at 180 degree. These are the two eyes for the ultrasonic sensor. This ultrasonic sensor can detect an object from 2 meters to 4 meters distance. Let me place an object in front of this. The region which is not covered by the sensor because of this obstacle is in green color, while the region occupied by this marker is in red color. Now we can see on the output screen, we can see the angle of the obstacle in which it is aligned and the distance from the sensor to the obstacle. You can modify your code in such a way that you can display the length and width of the obstacle too. The applications of this circuit are: the sensor can detect the object which is from 2 to 4 meters distance, and this is also applicable in robots like pathfinding robots and obstacle avoiding robots. This is also used to detect the wells and pits in the seas or any water banks, as the wave can penetrate to the water, and it is also applicable in submarines. This is how we can make a simple circuit using radar. Thank you for watching.